In this next section, we are finally going to look at some actual HTTP resale transaction data. So we're going to move away from our somewhat plain map of the regions of Singapore, now in hexagon format, and we're going to do this section. So we're creating again a Choropleth map. We're again using color to represent some kind of data attribute, but we're switching from a categorical data attribute to a continuous or quantitative data attribute. And with that switch, we will also see that we need a different type of scaling function. No longer can we use this ordinal scaling function, and we need a different color scheme, of course, because we can't use a categorical color scheme anymore. Now, the continuous variable or data that we are going to visualize is the mean price. So that is the average price in that particular location per square meter. And I believe the average in Singapore is about, 4,000 or so dollars per square meter. But we'll see, well, you can already see that here in this screenshot, that there's quite some variation. And as we can see too, that spatial variation kind of makes some sense with what we know about the city. We can see that the closer you get basically to the central business district, the more expensive on average HDB housing gets. So how does that work in practice? Well, we need to change just a few things. First, we need to change our ordinal scale to a sequential scale. Now, a sequential scale, again, is something that is offered by the D3 scale library, and it's a little bit like a continuous scale, but has kind of a special property in that sense. So far we've used linear scales, where we take the range, or the domain, I mean, of a certain column, and then we use that to translate that domain and data space to, in most of our cases, a positional kind of attribute. We're going to use that same logic, but we now need to translate these data values, these domain values, to a color attribute. But because we want to not specify every unique color all along all of these kind of small changes in the price, we need some kind of function to kind of automatically generate colors, and that is often referred to as an interpolator. And that's where this sequential scale kind of differs from the normal continuous scale. A normal continuous scale, like the linear scale, we set both the domain and the range. And in most cases with the sequential scale, what we do is we still set the domain, right? So the data part or data attributes, if you will, that always stays the same. But we, in this case, don't set the range, but we set an interpolator. And what that interpolator does, and we'll see that in a bit, is it will basically translate from whatever are the data values to a specific color. So how do you actually get these interpolators? Well, they are provided by that kind of sister package, D3 scale chromatic. And so far what we've used is, I'm going to scroll up here, we've used these categorical scales. Now categories, they're discrete and they're finite, so you can actually pre-specify, as is done here, a number of colors, 7 or 8 or 9 or 10. But for sequential scales, as you can see here, depending on how kind of tiny steps you take, there's almost an infinite amount of colors you can generate between kind of, in this case, we'll work with the orange scheme, between the lightest color and the darkest color. So that's why this package gives us the interpolate oranges function, which will kind of, no matter like how small the steps you choose, will generate a unique color that fits that exact data point. So we're going to use oranges for now, but you can switch it up later to blues or purples or whatever you want. So that's really the only thing we need to change. So let's see how that works in practice. We have here the same kind of where we stopped in the previous section. Same app.svelte, and we can see here. We can see here. This is the current map. So our task is we're going to change this now to a map of mean price. And if we look in the data container, just to make sure that it's actually there, we have all of these variables, and one of them should be, there we go, is mean price. And lots of them are null. That's what we talked about earlier. Those null values are basically where there's just no HTTP resale transactions and most likely no actual HTTP estates. And here we can see some of them actually do have resale transactions. And you can see here that that value seems to be pretty close to that $4,000 mark that I mentioned earlier. All right. So we don't need to change anything about the geo scale. The hexagons are in the right location. We don't need to touch that. All we need to do is change this color scale. So we no longer want to use an ordinal scale. We're going to change that to scale sequential, I think it was called, but I'm going to double check that just to make sure I spell it right. Here we go. Scale sequential. So I'm going to go back to Visual Studio Code. So here, scale ordinal, I'm going to delete that, change that to scale sequential, and then of course it's no longer available here either, so I need to change that too to scale sequential. Now, as you might remember from what we discussed a few minutes ago, the domain here is still needed. Every scale needs a domain. It still is derived from the hex dataset, and we can still use the domain method, but no longer do we want to use the region underscore n variable, but we want to use mean underscore price, which is this variable that we've seen here in the console is actually available. And then here is where it becomes a little bit different. We no longer want to specify a range, but we want to specify an interpolator. And it will basically function like a fancy range, if you will. So I'm going to change that to interpolator. And we can see that, we can double check that, especially if you don't believe me. Here, we can see here we have a domain method on that scale, and here we have an interpolator method. And what that does is, if interpolator is specified, it sets the scales interpolator to the specified function. Now, what is the function that we need to give to this interpolator? Well, that's that orange interpolation function, and it comes from this same package as scheme accent comes from. So it comes from D3 scale chromatic. But just to make sure I don't make any typos, I'm going to go to the README, and here we have interpolate oranges. So I'm going to copy that, and I'm going to say, okay, I no longer want the scheme accent. Give me the interpolate oranges. And that is the function that I then want to give to the interpolator. Now, I've changed my color scale. It is hopefully now a sequential color scale that will apply these oranges. So basically what we want to see is the higher the price, the darker the orange. But we need to make one more change, because previously what we did here is we mapped over every value and region name and applied this color scale. But we just need to change that, because we no longer want to map over region name, but we want to map over mean price. So now, once I save, we should see this map update. There we go. And that looks like it's about the same as in the course material. Now, just to reiterate, we have now used oranges, but if we wanted to use a different color scheme, all we needed to do, let's say we wanted to use purples, we just copy the purples here and here as well, and we save. And then we should have purples. There we go. And that's our linear scaling of the mean price.